everyone. So today we're going to start our new unit. It is going to be activity 5. I'm hoping that today you'll be able to graph a coordinate point and define the domain and range. Now this unit is very big on vocab. So when I see your guys' notes, I want to see all these vocab words written with the definition for full points. Again, it's super important, so that way if I give you an open notes test, you know what these words mean. Super important. So take your time, make sure that you're copying down these vocab terms, press pause, and then play the video when you're ready to move on. All right, so let's start with our first vocab of today, which is coordinate plane. Now, a coordinate plane is just a fancy way to pretty much say it's just an image formed by the intersection of two number lines. So a lot of people will think of a coordinate plane as this right over here. Pretend these are straight, by the way. That is a coordinate plane. That's just putting a name to it. Now, notice that these two lines, one of them is horizontal and the other one is vertical. The horizontal axis of the coordinate plane, this guy right over here, is called the x-axis. The vertical line, which is this one right over here, is called the y-axis. And I'm sure most of you guys have seen this in 5th and 4th grade, but I want to make sure you guys understand it before we go on with what we're trying to cover. So notice that when you make these, the x and the y-axis, you have a coordinate plane. And you also created 4 different spaces. The space here, space here, space here, and space here. Those are what we call quadrants, the 4 regions into which the x and y-axis separate the coordinate plane. Now, we actually have a special way of numbering these, and it kind of works like a backwards clock. This first coordinate over here is called coordinate 1. This one over here is called coordinate 2. This one right over here is called coordinate 3, and then this one right over here is called coordinate 4. Now, keep in mind there that I wrote those in Roman numerals. I don't know why, but they always seem to write them, but it doesn't matter. All you have to say this is coordinate 1, coordinate 2, coordinate 3, and coordinate 4. The reason why I wrote the Roman numerals, so if you have a homework assignment, you've seen this before. You know that those are just the Roman numerals. But these regions are not going to change. That region 1 is always going to be 1, 2 is going to be 2, and 3, and so forth and so forth. So those are the coordinates. Now, to go a little bit further and add some more vocab, let's talk about the origin. The origin is just the point at which the x and y axis intersect on the coordinate plane. So if I look at my x and y intersect, they intersect right there in the middle, and that middle point there is called the origin. It's where they meet. And finally, our last one is called ordered pairs. An ordered pair is just a set of numbers or coordinates written in the form x and y within parentheses. And of course, we're going to get a little bit into how to graph these ordered pairs, but the majority of the thing that you have to get from this is that you have ordered pairs. The first number that's listed is known as your x value. The second number that's listed is listed as your y value. So as long as you have that, we're going to practice a little bit with putting them on coordinate points as well, making sure you understand the basics here. So before we start getting into using these vocab terms, let's talk a little bit about graphs and give you more vocab. There are 2 types of graphs that we are going to be covering. One is called the continuous and one is called the discrete. A graph with a line or a smooth curve is known as a continuous graph. So if you have any graph just like this one and it is smooth and continuous, notice that I could write this graph without lifting my pencil. It is called a continuous graph. Now, let's say you have a discrete graph. Well, a discrete graph consists of points that are not connected. So I can have a bunch of little small coordinate points everywhere. This is what is called a discrete graph. So you pretty much just got to know how to look at them for now and just know that, okay, this is a continuous graph and this is a discrete graph. We're going to be focusing the first couple days on discrete graphs and learning some more vocab and some more math while we learn that. So as of right now, if you know these 2 words, you're doing great. Okay, so continuous and discrete graph. And again, you could do whichever one. You could write this as any type as long as it's connected and it's a smooth curve. So there's some more talk here that I want to cover. Let this take a picture real quick. All right, so these are some more definitions that we need to know for today. The first one that I want you to know is what is a relation. A relation is just a set of ordered pairs. So what I'm trying to get at here is that if you have some ordered pairs like 2 and 3, and they can be whatever you want, 3 and 4, that is just a relation. Every number or every pair within those parentheses, each ordered pair is in a relation. 2 is in a relationship with 3, 3 is in a relationship with 4. Those are what are called relations, just a set of ordered pairs. Now, in order to show the set, that means that, hey, I want to tell the reader that this is everything that I have. I'm going to put these little fancy math brackets to tell the reader, hey, this is the set. These are all the ones that I'm looking at. These are the ones I'm talking about. You have to include these little fancy math brackets, is what I like to call them, when you are listing things in your done listing. So that is what is called a relation. It's just a set of ordered pairs. You might have 1, you might have 2, you might have 1,000, but that is all a relation is. Now, each relation has a domain. The domain is a set of the first numbers, the x values of the ordered pairs in the relation. So remember that your x is always going to be the first number listed. That means that that is your domain. Your domain is whatever those x's are. So notice if I have a domain here, and I'm trying to tell you my domain is, they are just going to be the x values. So it's just going to be 2 and 3. Now, 2 and 3 are the only x values there. I have listed everything, so I have to tell my reader, but with those fancy math brackets, that, hey, I'm done listing here. Now, let's look at our range. Our range is known as the second numbers, the y values of ordered pairs. So let me change color so I can show a little better. These are my y values, the second one's listed. If I were to tell you, hey, what's the range of this? You would just tell me with those little fancy math brackets and say it's 3 and 4, because those are the only y values there. Now, what else is listed there is, or what else we have to know, is called a mapping diagram. And this just literally illustrates each element of the domain is paired with each element of the range. Now, element just means item is what I like to think about them. In order to do a mapping diagram, you're going to need 2 circles right next to each other. The first one's going to list your domain values, aka your x values, and the second circle is going to consist of your range, your y values. Now, if you were told to put this here, this relation, in a mapping diagram, again, you're listing just your domains right over here, so 2 and 3. On the right, you're going to list your range, which is the 3 and the 4. I don't know why I underlined that, but I'm going to erase it just to not confuse you. And then this is where the mapping comes. You have to tell me which element or which item is in relationship with which. So if I look at my first one here, 2 is in relationship with 3. So I'm going to write an arrow, or a mapping arrow, showing my 2 going to the 3. My second relation is 3 to 4, so I'm going to write an arrow from my 3 to my 4. And that's all mapping is, and you'll see why that comes into handy in a second when we dive into more of these problems. All right, so let's talk about functions now. A function is just a relation in which each element of the domain is paired with exactly one element of the range. So just to put in simple terms, every x value has exactly one y value. So just memorize that every x value has exactly one y value. Whenever I ask you, hey, is this a function? That's all you need to be thinking in your head. Does every x value have exactly one y value? So that is pretty much the definition. We're going to start doing problems involving these. If you're still a little confused, take some time, try to understand those so that way it makes sense when we cover these problems. All right, so let's start with this first problem here. And what I'm trying to do here is I'm trying to get you guys to be able to see an ordered pair, a table, a graph, know how to find the domain, the range, put it into a mapping diagram, etc., etc. So let's start with this first one. Notice I first gave you ordered pairs. Now, whenever you have ordered pairs, you're going to have a certain amount of parentheses. Each one of those parentheses represents a relationship, an x to a y. Now, this ain't the only way we can represent each one of those relationships. We could also put it in a table. Whenever you want a table, I want to see an x and a y, and then I want you to list the pairs. Notice you have 3 pairs to list here. The x is always listed first, the y is listed second. So here's my x's and y's for each of the ordered pairs. I'm going to start with this one first. So notice I have a 5 and a 5. My second one is 2 and a 3, and my third one is a 4 and a 5. Keep in mind there that I did not put them in any specific order. I just listed them within my table, and that is what I want you to be able to do. I want you to train your mind that when you see those ordered pairs, you're seeing that table. And when you see that table, you're seeing those ordered pairs. Now let's put these in a graph. Remember, we're always going to graph in a plane, So if you don't have a coordinate plane, just put a little quick x and y axis, and then start plotting your points. Remember, each one of these relationships represents a relationship. X is x in relationship with y, this x in relationship with that y. You just have to list them. So 5 and 5. My x is 5, so I'm going to go 5, 1, 2, 3, 4, 5 in the x direction. Now I'm going to go 5 in the y direction. 1, 2, 3, 4, 5. So my point is right over there. My next one's 2 and 3, so 1, 2. 1, 2, 3. It's going to be right about there. And 4 and 5. 1, 2, 3, 4. And 5 is right up over here. So again, remember that your x is listed, your y is listed next. And that's pretty much it. You train your mind that these three things are telling you the exact same thing. You just got to be able to do it. All right, so let's start with our mapping diagram. Remember, domain goes to the left, range goes to the right. My domain in this situation is a 5, 2, and 4. I got them from just looking at my x there. And then my y's there are 5, 3, and 5. Now, keep in mind there that 5 is listed twice. You should not be listing any of the domain and ranges more than once because you're telling your reader unnecessary information. You've already told me that there is a y value of 5. If you write down an element more than once, then you'll be marking correct. Now let's do the mapping. 5 is in relationship with 5, so it's going to go right over there. 2 is in relationship with 3, so it's going to go right over here. And 4 is in relationship with 5, so it's going to go right over there. Now, what would my domain be again? My domain is just all the x's, 5, 2, and 4. Remember, you have to include your fancy brackets in order to do that. Your range is going to be your y values, which is 5 and 3. And remember, whenever you're listing domain and ranges, you never want to list elements more than once. Now, is this a function? Does every x value go to 1y? Well, this x does. This x does. This x goes to 1 as well. They all go to 1 y value. So that means that, yes, this is a function. I have no clue why it was pasted twice, but just ignore it. So I know it seems like a lot of vocab right now, but the more practice you get, the better you'll get. So let's go with the next one. And I'm going to go with a little more speed so that way you can see how it's not going to take you too long. So I have a set of ordered pairs here. I have an x and a y, an x and a y. I have 4 and 5, 5 and 5, and 3 and 4. And again, all I'm doing is just reading off each one of these. Now notice that I did make a mistake and mixed up my x and y. Do not do that. Don't be like me. And let's start graphing these. So here is my coordinate plane, 4 and 5, 1, 2, 3, 4. 1, 2, 3, 4, 5. It's going to be somewhere right over here. 5 and 5, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. It's going to be right over here. And then 4 and 3, 1, 2, 3, 4. 1, 2, 3. There you go. So that I have that done. Now let me go ahead and do my mapping diagram. I always like to look at my table because my x's and y's are a little more isolated there. So notice I have a 4, 5, and a 4. So pretty much I only have 4 and 5. For my y's, I have a 5 and a 3. And now I have to do the mapping. 4 is in relationship with 5. 5 is in relationship with 5. 4 is in relationship with 3. Now, does each one of these x's have only one y? Does this x only have one y? And the answer is no, because it has 2 y's. That 4 specifically has no 2 y's. So no, it is not a function because that specific x has more than one y. When x equals 4, y equals 5 and 3. So when you are doing these problems, if it's yes, just tell me yes and move on with your life. But when it's no, I want you to tell me which x value has more than one y value. Now let's just finish up the domain and the range real quick. The domain here is going to be a 4 and a 5. Do not forget your fancy math brackets. And then 5 and 3. All right, so one more example. I know this video is getting kind of long, but I think this will be it. So looking at these ordered pairs, notice I have a table. The table here is 6 and negative 2, 3 and 4. So all these are in a relationship. So I have to put all those in ordered pairs. So 6, comma, negative 2, because that is an ordered pair. 3 and negative 4. Notice that order doesn't matter. All I need to do is list these away. Then I have 1 and 0. Remember, these are all of them, so I'm going to put my fancy math brackets. In order to graph these, I'm going to graph a lot. 6 and negative 2, 1, 2, 3, 4, 5, 6, 1, 2. 3 and negative 4, 1, 1, 2, 3. And negative 4 is 1, 2, 3, 4. Just roughly right about there, 7 and 0. It's going to be one more, 1, 2, 3, 4, 5, 6, 7. 8 and negative 1, so it's going to be one more, and then negative 1 down is going to be right about there, and then finally 1 and 0. So double checking, I had 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5. I have all my 5 points there. So that's pretty much the graphing. Let's do the mapping. So I have 6 and 2. So again, what I like to do, it doesn't really matter as long as you have the information. I like to just write down all my domains and ranges when I do this, and then I go back and worry about one thing at a time. And I'm not going to be picky if you go outside the circle, as long as you get the general idea. The mapping is what is important for today. Okay. Now notice I listed them all right away. I'm going to double check to make sure I didn't write any twice, and I did write the 0 twice, so I'm going to erase that to make sure it's there. Now I need to do my relationship. 6 in relationship with -2, 3 is in relationship with -4, 7 is with 0, 8 is with -1, which is there, and then 1 is with 0, which is right over there. Now, is this a function? The answer would be yes. Why would it be a function? Because again, every x value has to only have one y value. This x value is listed over here goes in one direction. This 3 goes in 1. This 7 goes in 1. This 8 goes in 1, and this 1 goes to 1. Every x value has one y value. Notice it doesn't matter how much each y value has. We're only worried about the x's here. So that's pretty much it. I know this is a pretty fairly long note, but again, it's just going over a lot of vocab, so that's why I probably took a little bit more. But be patient. Make sure you write down the vocab.